In this video, we are going to uncover even more patterns hiding inside numbers, making multiples and the least common multiple, LCM, super simple. Ready to get started? To begin, let's quickly refresh our basics. Remember how we built numbers using prime cards? For example, to create the number 15, we attach a card of 3 and a card of 5. That's how we get 15. But before we proceed, I have a question for you. What do you understand by a multiple of a number? And how can we build the multiples of any number? Think about it for a moment. Fantastic! If we multiply a number by different whole numbers, like 1, 2, 3, and so on, we generate its multiples. In other words, building multiples of any number involves attaching more prime cards to the original number. Now, let's dive into creating its multiples. What happens if we attach no additional cards? Pause and visualize. Exactly. We still have 15. Now, what if we attach a card of 2? Take a moment. Yes. We get 30. And if we attach a card of a 3? Perfect. We get 45. What cards do we need to attach to get the next multiple of 15? Great thinking. We will attach 2 cards of 2, giving us 60. And what about the next multiple? You are right. Attaching a card of 5 will give us the next multiple, 75. Look closely at the multiples we have built. Notice something? That's right. Each multiple contains the number 15 within it. Can you tell me why? Exactly. This is because we formed multiples by attaching cards to the original number. Now, can you continue to build the next 5 multiples of 15? Take your time and try it out. Excellent! You have done a fantastic job building those multiples. Now, let's take another number, say 12, and build its multiples using the same method. What multiples did you get? You got it! The multiples are 12, 24, 36, 48, 60, 72, and so on. Superb work, everyone! Does each multiple of 12 contain the number 12 within it? Do you see any patterns in the multiples of 15 and 12? Observe closely. Yes. Some of the multiples are identical, like 60 and 120. These are common multiples of 15 and 12. Therefore, a common multiple of 2 numbers is a number that contains both original numbers within it. Now, let's explore further. Which is the smallest number that contains both 15 and 12? Think about it. Excellent! But how do you know 60 is the smallest number that contains both 15 and 12? Exactly! If we look at 60, we see that it includes both 15 and 12. However, if we start detaching cards from this number, it will no longer remain a common multiple of 15 and 12. For instance, if we detach a card of 2 from 60, the new number contains 15 but not 12. Similarly, if we detach a card of a 5, it contains 12 but not 15. And if we detach a card of a 3? The new number doesn't contain either 15 or 12. Fascinating, right? So, 60 is the smallest number that is a multiple of both 15 and 12. This brings us to an important concept, the least common multiple, or LCM. The LCM is the smallest number that can be divided evenly by each of the given numbers. Or we can think of the LCM as the smallest number building we can build that contains all the given numbers. You might have learned a few methods to find the LCM, like listing the multiples of the numbers, finding the common multiples, and identifying the LCM. Or you might have used prime factorization, where you find the prime factors of each number and multiply the highest powers of each prime factor together. Another method is the division method, where you divide the numbers by prime factors until all are reduced to 1, then multiply the prime factors you used. Finding common multiples and LCM using these methods is not always easy to understand, right? But don't worry. We have covered the basics of multiples and the concept of the least common multiple. In the next part, we will explore 3 visual methods to find the LCM, which will make it super simple. Stay tuned and get ready for some more exciting discoveries.